G'day YouTube. Yeah, just thought I'd do a quick video on a little inverter generator repair that I'm underway with. Bought this little generator off Facebook Marketplace here. It was 150 bucks. The gentleman that I got it off claimed it had a fuel leak and wasn't running. I got it home and there was also no spark, which is a little bit of a concern with these new inverters, depending on the control board or inverter board here. However, this one appears to be in really good nick, and I think I've found what the cause of the no spark, and I've definitely found where the fuel leak's coming from and done a repair on that. Sorry for it's been so long since I put a video up on YouTube, but yeah, I thought you might find this interesting. So I didn't film taking the side cover off. It's pretty straightforward, just a whole bunch of screws along here, a couple from the back, and then the handles on each end, they just pull out. So essentially once you take that front cover off, front panel, the side just comes off and you're left with this. Disconnected the breather for the top of the fuel tank here, and the supply to the carburetor goes from this line, so that's off the bottom of the tank. Might show you the damage on the tank, or what we found and what I think's actually happened here. So this is the tank. What we actually worked out was this. If you're looking, it's probably too hard to see inside, but I end up there was a crack all the way along here, right on the seam, and you'll see that I've soldered this all back together prior to putting this JB Weld tank repair kit on, or putty, I guess you'd call it. We ground that back into a V and then used some plastic to actually weld the seam. It was cracked from about here to here. He'd done a temporary repair before. He'd done a horrible job, so I couldn't get a new tank, so I ended up having to. I don't like doing this type of repair, but there was definitely, you could not buy a new or a second-hand tank anywhere. So yeah, just ran the soldering iron along down there, swirling it as I went, and just kept sort of pushing the plastic back in until I fixed the crack. And then I've used this JB Weld over the top. But I believe what's happened, this tank has been dribbling, a bit like me at times, dribbling. Down onto the back of this front plate here, the output plate. So when this is in position, sort of in here, this sort of sits here, where the ignition module sits up the front here. I believe some fuel has actually dribbled down onto the back of that, and that's caused the no spark issue. This is actually, so what it looks like when you pull your generator apart, you'll actually have that. That's obviously your power good, your overload, and your low oil light. But this also acts as your ignition module. It's actually called a spark unit or ignition module. If you look very carefully in there, you'll see that there's a little capacitor in there that's actually blown. It's actually leaking fluid out the top, and this was covered in petrol when I pulled it out, whether from an overfill or from that cracked tank. I'm not 100% sure, but you can just see it in there anyway. New parts ordered. I did manage to find this exact part number online, 2KWD1A1200003. It was actually I got it off AliExpress. It was for a completely different generator. You cannot get this part. Especially, you can't get this part with this type of plug. It's a 10-pin plug, but it's stacked 5 at the top and 5 at the bottom. You can get a Kipor generator module, which looks identical very cheaply, but it's got a 10-pin plug. And I actually worked out, and I'll talk about that a bit later on, but I actually did work out that I could have grabbed the Kipor generator ignition unit and repinned this one to make it work if I had done a little bit more homework and a little bit more research prior. But anyway, I believe that's the problem, why we've got no spark. I'm going to run you through some tests I did to get to that conclusion, and I'd really like to thank a couple other YouTube subscribers, and I think it's the Smokestack forum. There was a guy on there, DBE, who was very, very helpful around this module. He's a legend, or she is a legend, so yep, there we go. I'll just pull up there and I'll get this generator turned around so we can show you where we started. Yeah, so guys, I just pulled the side cover off for us, just so make it a bit easier for everyone to see. Very simple, just screws along the bottom here essentially, and that cover just falls on the crown. Don't ask me how I know that. So I bought myself this little spark plug tester. You don't really need it, but it's just handy. So I'll just show you how I diagnosed the no spark condition. So I put, see my little spark plug tester on here. It's a bit fiddly sometimes, it doesn't like clicking on. There we go, so she's on. Plug this guy into our coil. And obviously when you plug that module back in just for now, so you got a view of it where it isn't actually working. Obviously you want your engine to be in the running condition. Spark plug tester's in. Let's give him a pull and this should light up. As you can see, there is nothing, absolute nothing. This fuel tap is actually the kill switch as well on this machine. You can see here, when you push this, come around from the top, mate. When you push this across, you see it engages this micro switch and that grounds the spark to the engine frame and kills the engine. That's actually the running position there, I believe. Coal start. And that's the running or restart position. So yeah, if it's like that, you definitely won't get any spark. But as we can see, definitely no spark. There it is. Change the spark plug out. This should still light up even if the spark plug is no good. So even by putting a new spark plug in, it's still definitely got no spark. I guess so. The next thing I checked was the coil. I just pretty much started at the top and worked my way around. So to test the coil, obviously you got this little, it's actually positive and negative from the primary side of the coil. So the yellow wire is actually the ground. You can see this black wire here is actually plugged into the yellow, if you look closely there. And then you've got the blue to obviously the blue. So what we're going to do is just disconnect this plug for a second. We've got access to our coil wires here. We'll grab our multimeter, I'm going to put it on ohms. I should have got my good multimeter, this will do for now. So first thing I checked was obviously the primary side of the coil. So put our ohm meter on one side, and you have a look at the multimeter, we got 1.2 ohms. Now I wasn't 100% sure on the values on this. You also got to deduct the resistance in your multimeter cable, so we're about 0.1, so at 1.2 we're actually 1.1 ohms. I looked on the net and I found anywhere from 0.8 to 1.5 depending on the brand. I couldn't find a maintenance manual on this. I did find a wiring diagram though, and I'll show you that in a minute. And obviously off the smokestack forum, that sort of tested about right. So I had no issue with that. The other test you want to do is go from, obviously you can take either wire. Let's go from that side back to the secondary side of your coil. Put our meter in there and we can see we've got 10.67 thousand ohms. We jump to the other side, they should be the same in both directions. So I was very confident that there wasn't an issue with that coil if they measured differently between like either open circuit or way ridiculously high resistance across here, or there was a difference on one end of the coil to the other. I'd suspect that definitely, and we would have replaced it. These are like the old magneto type coils. If you look from the front, there's normally on the old style coils, you remember you had the magnet spinning past, and that was what generated the magnetic field, which obviously induced a current, which gave you the high tension spark. They don't work like this anymore. These newer generators rely on the ignition module. They've got a little pickup on the stator inside, so when the engine's spinning, the little pickup or trigger coil they call it, as the engine spins, magnet spins past, it knows to fire. This is powered, and then that sends a signal to primary side, which then allows the high tension lead to spark. So I was comfortable with that. So I didn't. I was happy with the coil. Plug that back in so I don't forget. All right. So the next thing we want to check is there's two main issues apart from the coil, and probably more importantly, that go wrong with these little clone Honda engines, I guess you call it, because they are literally, they look so similar to the little EU engine. You obviously want to check that your oil is full, because they have a low oil shut off. I've already done that, and I forgot to mention that earlier. It was down a tiny little bit, but made no difference. I topped it up to the full mark. Nice fresh clean oil in there. I won't take the cap off because I did overfill a little bit and it drips. I've just finished cleaning it all. However, if you look in here, you'll see an orange wire right here. And generally, if you look at the wiring diagram for this, that orange wire is the kill signal for the spark. So I did find this in the back of the owner's manual, but essentially you can see right, I think it's that one there, yes, I'm very blind, so oil level switch. And if you follow that guy around, it actually tells you it's an orange wire that goes to that spark unit or that ignition module that we're working on here. So we tested, the way you test that is you test it to make sure it's not shorted to ground. So that's very simple. I'll just show you that real quick. Set our multimeter on continuity. That's how I do it. I actually originally removed, I just pulled it forward to get to this, but there is actually a spot in here where I can check this, and when I check it, if I touch anywhere on here to ground or back probe the connector if I can, I'm not sure if I can get into this one. Anyway, if you touch on that side of that wire socket and you do that and you get a beep like that, there's an issue with your low oil sensor. It shouldn't do that, it should be open circuit. So if I'm touching in there on that wire and I touch here or anywhere on steel on the motor, for example, I don't get continuity, which means that switch is good. So there's no issue there. Obviously the next thing you want to check is if the actual little kill switch here, which is our kill switch, is not shorting the spark to ground. So the simplest and easy way to check that switch is literally just to disconnect it, and you'll see that there's a little connector here. So if we unplug that, you pull the engine over with your spark connector connected. If you get a spark, well then you know what your issue is. You've got an issue with this switch. I don't. I've disconnected that, tried pulling over, there's still no spark. I've checked the circuit. So for example, if I hold my multimeter over those two wires, I don't get continuity, which is what you want to see. As soon as I close that switch, it should get continuity, which means that switch is functional. There you have it. In the run position, there should be no continuity. And there isn't open circuit or out of limits. I'll just plug that guy back in so I don't forget. And just remembering all of these wires, they do head down. If you have a look here, they all head down to that module. So this black, brown, white and grey all come directly from the control board or the inverter board into this plug, the bottom half. Yeah, so obviously there's our orange wire. So that would this module grounds that wire for low oil. You've got obviously a red wire, that's actually that engine kill switch wire up here. So that wire is for the engine kill switch. This black down here, now this is where I had to do a little bit of research and find the correct wiring diagram. Took a bit of time, but that's definitely a ground. So that wire down here is just a ground to the engine frame. There's a black wire right beside that red guy there. That black wire there actually heads to the ignition pulse generator. So that's the little guy I was talking about before. When you pull the engine over, it sends a signal up to tell this guy when to fire or when to send signal to the coil. This blue wire, it's called Azure. I found that, I thought it was Yeah, okay, I might be colourblind, I thought it was turquoise, but anyway, it's azure. That light blue azure wire is the exciter winding. So there's a number of windings inside the generator. We can test that. We can test all of these, and then I can link you to the smokestack forum. Pretty much it's the same as a Kapoor control module, but there's all different values for the different windings. So you've got. So let's unplug that module and we'll do some further checks. So we've got continuity. We know that that wire there is the engine kill wire, and we can test that by touching the red up here on the switch. So we know that's that wire. We know that that one down there on its own, the black on this corner of the plug, is a ground, as you can see. Again, that orange wire, like I said, is that orange one down there going to the low oil light. And then that blue, dark blue wire we haven't talked about is actually the coil. So that's this guy up here, this blue coil wire. If you were to touch, let's just back probe if we can. Might be able to get it for you. So that's the coil wire. And then the last remaining two is, as I said, you got this light blue azure wire color, and then you've got this, it's pretty much those two side by side there. So you've got, whoops, the black and that light blue wire together. So what we'll do, we'll check this winding first. So this is the igniter ignition power wire, or igniter power wire. Now, essentially, if we just go again to our ohm setting, range selector, diode, there we go. And let's just go, it doesn't matter which lead you use, let's go from there back to a good ground and see what the ohm reading is. Might just use a different ground. There we go. So we can see it's about 1.2 ohms. Again, in the online, I found references to 0.8 to 1.5. So without having the manual, I'm saying that the exciter winding for the power for this module, it tests, in my opinion, tests okay, and it matches what a Kapoor, roughly what the Kapoor generator should be. So I was happy enough to say that the power winding for this module was fine. So the only one we've got left is the black wire. So that black wire is the ignition pulse generator. So I think it was around 120, 130 ohms that should read. So essentially, if we just go, which is it? 1, 2, 3. So it's that third pin in. Go to a good ground. There you have it. So it was 131.5 I got, minus my, it's 131.3 because of my leads. So that checked out. That checked out very similar to what the Kapoor generator was that I found a bit of info on those smokestack forum and a few other places on the internet. So I guess the only other tests I did on this plug was, you can't really do too much with the invert. These wires here, this black, brown, white and grey from the inverter that I could find. But what I did do was put my meter onto the voltage AC setting. I then probed from the light blue azure wire, which is your exciter winding or ignition power winding. I pulled the generator over, and I think it was meant to be reading roughly about 12 volts from memory. Don't quote me on that. However, I did see like 5 or 6 volts on that every time I pull the engine over. Now this is a digital multimeter. To get a better reading on that, you should use an analog meter. I've been caught with that before. I'm actually quite happy with the reading I got because of the digital meter. I think it'd be a lot higher if I used an analog meter. However, reasonably comfortable. There's no problem with the exciter winding there. I then put the same test, but just went from that black wire there beside the red, and I put it on voltage again. I then pulled it over, and I got like 2 or 3 volts, and you could see as the engine would spin, it would jump up and down. You could see every time the magnet went around, it would make the meter fluctuate. Again, an analog meter would probably give you a better reading. I think it's meant to be 5 or 6 volts on that wire. I was getting, like I said, 2 or 3. So pretty comfortable, but there's no issue with the output from the exciter winding or the trigger coil. The only other thing I could think to test was maybe there was something to do with I've heard that if the control board and inverter board is faulty, or there's no output from the actual stator that produces the power when the motor's running, which is this plug over the back here, and I'll unplug that in a second, that can cause a no spark issue as well. So essentially the power comes in, there's two circuits there. So there's 3 wires from the stator of the motor, and there's also 2 other, so it's the main winding, and then you've got a sub winding for DC. So essentially that's the next plug I checked, and we'll do that now. I'll just unplug this. Oh, there we go. So as you can see, and this is where my wiring diagram varied. It's the color that it told me these 2 should be was incorrect. These 3 black wires are the ones we're interested in right now, which are your stator windings from the main winding. So essentially it's wired as a wire configuration. So if you test from this pin to any of these 2 here, or in any way, as long as you're testing any of those two pins out of the 3, they should all read the same. However, if you're testing any one of them, because of the wire configuration, you're testing all 3 anyway. It's just the way that works. So let's put that in ohms. Yeah. So yeah, we'll put our pins in there, and you can see we get 5 ohms. If we test any of the other legs, we get 5 ohms, and no matter which way you test this, if they're all equal, and roughly I'm guessing that 5 to 6 ohms from what I can sort of read, there's no issue with your main winding on your stator. So we've tested all legs in every direction. There's no need to do this, but just to validate what I said, there you go. So the only other check I could do was on the DC windings here. So if we put our probe there and there, on those 2 pins, we get 0.6 of an ohm. I couldn't really find a figure on that better. We'll try it on AC volts on the main winding, see what we get. It's like at least 24 volts there. 21 volts. So I was pretty comfortable that there was no issue here. And the only other component I had to look at, which doesn't make any difference to the no spark condition, was down the back here. We have a look down inside there. There's an actual bridge rectifier, so that takes AC, converts it to DC, and I'm not 100% sure. I think this outputs in AC, and then the bridge rectifier converts it back to DC for the DC outlet on the front of the machine. Just don't quote me on that either, but I'm certain that I know that it is a bridge rectifier. There's a fuse down there in that white capsule. It wasn't blown, but that has no impact on this not outputting spark from what I can see. So there was no issue with any of that. So then I went, okay, well the last thing that I could test or have a look at was this guy. And that's when I noticed the blown cap in here, and that this is a reasonably common failure for these type of generators. So yeah, so what I'm going to do, I'm going to make this as part 1 of this video, and then when the part turns up, I'll put it back together, and hopefully we got spark and I don't look like a goose, and we'll put the generator back together. Yeah, thanks for watching everyone, have a great day.